How about day 2? At day 2, the available beds are 30. So which variable you have? X1 do you have or not? X1 is 1 day stay. So we don't have X1. Because at day 2 they leave the hospital. So X2 we have at day 2. They come as for 1 day stay. Then Y2 and W2. These are new patients at that come at the second day. How about Y1? Do we have Y1 here or not? Y is 2 day stay. So when they come at the first day means still they are sorry. Still they are at hospital. So Y1 also we have. And also W1. Because W1 is they stay for 3 days. So when they come at the first day, they stay until day 3. Should be less than or equal 30. How about day 3? Day 3, you have X3, Y3, W3, and how about X1? We don't have X1. We don't have X2 because X2 is 1 day stay. W1 and Y1. There is Y1 or not? Because it's 2 days. So the last 2 days they leave the hospital. How about Y2?
Yes.
Okay, at Y2 they come at the second day, so stay until day 3. And W1, because W1 is 3 day stay. So 3 day stay means first day until day 1 until day 3. So at the third condition we still have W1 and we have W2. The people that come at day 2 and stay for 3 nights, 3 days, should be less than or equal 30. And day 4, we have X4, Y4, W4, X1, X2, X3, they leave the hospital, so we don't have. Y1 is 2 days stay, so we don't have. Y2 is day 1 and day 2 and 3, we don't have. Y3, we have because they stay 1 day 3 and 4. Then W1 is finished because it starts from day 1 to day 3. W2 and
W3.
W3. It should be less than or equal 30. So these are all the conditions that you have. Here, the number of the patient you can, it's better you write less than or equal because they expected for 1 day set they expect 30%, but it's maybe less than 30%. So it's better you consider less than or equal 30 instead of equal 30 for summation of xi's. And this is for number of patients for staying 2 days, number of the patient for staying 3 days, Then the limitation for available beds for each day. Day 1, day 2, day 3, and day 4. So, which one is goal, which one is constraint? Which constraints are goals for this problem? Which one are goals? So they use goal programming to resolve the problem of over-admission and under-admission at hospital. So it means that if the hospital can accept all the patients at each day or cannot accept. So it's about the goals are number of beds, not number of patients. The patient is not goals of for hospital. So the patient can come or can not come to the hospital. Means that the first 3 are constraints. They are not goals for the hospital. The rest 4, 5, 6, and 7 are goals for the hospital for this problem. So we have 3 constraints and 4 goals. Means minimize G1, G2, G3, and G4. G1 is the goal of reaching the available bed for day 1, G2 for day 2, G3 for day 3, and G4 for day 4. So, before you write the objective function, at the first, you cannot write the objective function. First, you should add divisional variable to the goals. First 3 constraints we don't change because they are constraints. For the last 4, we add divisional variables. After you add divisional variables to all the goals, then you look at the original constraint. The original inequality for all of them is less than or equal. You see at the right whiteboard, you can see the original goals are less than or equal for all of them. So it means that for objective function, we should choose S plus. because the original is less than or equal. After you add divisional, for violated goals, we should minimize Si plus. So, means that first you should write like this. G1 is equal to S1 plus, G2 is equal to S2 plus, and G4 is S4 plus. So we have 4 goals. So after you write the constraints, you cannot directly write this one. First, you should add divisional variables. Then you should write your goals. Your goals is minimize G1 to G. This one should be G3 and 4. G1, 2, 3, 4 equal to S1 plus, S2 plus, S3 plus, S4 plus. After you find out which divisional variable you consider positive or negative, then you should look at the information at the problem, that what is the weight for the problem. So here you can see all the goals have equal weights. Here, even this problem mentioned you that only the weight limits represent flexible goals. But if it doesn't mention to the limitation of weight is goals, you should find out that only the goals are for weight. So here, the question also mentioned that only weight limits represent as goals, and all the goals have equal weights. So means that W1, W2, W3, and W4 are equal to 1. Because they have equal weights, so means that I can write the objective function like this. All the goals have equal weights, means that W1, W2, W3, and W4 are equal to 1. Don't confuse with this W. This is the weight. For objective function, the weights are equal to 1. Not that variable that we use at the program. Then this is the optimal solution. After you solve the problem, you see objective function is 0, means that all goals are met. Because z is 0, means that all goals are met. And for the variables, you see all the SI's are 0. So first consider the example 3.1. We consider the first case change of the right hand side by using graphical method. So we solve the problem by using graphical method and see what happens if we change the right hand side. So the job code produce two products on two machines. A unit of the product 1 requires 2 hours on machine 1 and 1 hour on machine 2. For product 2, you have a unit requires 1 hour on machine 1 and 3 hours on machine 2. So the revenue per unit product is 1 and 2. For products 1 and 2 are $30 and $20. So the objective function is maximize X1 for product 1, X2 for product 2. X1 is number of units of product 1, X2 number of units for product 2. So the objective function is maximize the profit or revenue, that is 30x1 plus 20x2. And the total daily processing time available for each machine is 8 hours. So now you write the constraint. You can see is 2x1 plus x2 less than or equal 8 because it said that the product product 1 requires 2 hours of machine 1 and 1 hour on machine 2. So it's the coefficient is 2 and 1 and the available time for each day is 8 hours. So it should be less than or equal 8. And you do the same and the constraint for machine 2. And variables should be non-negative. So by using the graphical method, you sketch the lines 2x1 plus x2 equal to 8 and this one is first constraint and
加 S1 S2 加正加 S minus 1全部这里，然后
this one is the second constraint. This is a feasible solution, and after you find corner points, these are corner points. Point C, this point C is optimal solution. So the value for x1 is 3.2, for x2 is 1.6, and value for z is 128. So, what happens if I change the right hand side for machine 1 to 9 hours? So, if machine 1 can work for 9 hours per day, what happened to the optimum solution? Does it change or not? So, we said that we change 8 to 9. For machine 1. So what happened if we change 8 to 9? When you change 8 to 9, at the graph you should sketch the new line. The new line is 2x1 plus x2 equal to 9. So if you sketch this one, you have a line parallel with the previous one. When you sketch the new line with right hand side equal to 9, if you consider right hand side for first constraint is equal to 9, after you sketch you have the new line, and it's parallel exactly with the previous one. Because the coefficient of the variable doesn't change, only the right hand side is changed. So, means that this point, this is your optimum point, point C. After you change the right hand side for first constraint, it comes to this point. Change to this point. This is point G. So if I change the right hand side for first constraint, the optimum point is changed to G. X1 is 3.8, X2 is 1.4, and the objective values is 142. So means that with this change, optimal solution also is changed. This different change we call duality. The value of the change for optimum solution, for optimal answer, we call it duality for this program, for this problem. Then we can calculate that how much is the duality for this problem. So how much the value is the change is from 128 it changed to 142. The difference is 14 units, $14. The difference of the change for the profit, for the revenue is $14. The new value minus old value of the Z. So how can I find out these values? We call dual price. This 14, the delta Z, we call it dual price. We use this formula. Rate of the change for optimal solution. When we change right hand side of the constraint, we use this formula to find how much is the rate of the change for optimal solution. So this is the formula. Z of G means the new value new optimum solution minus old objective value divided by capacity of the change. So how much we change? We change 8 to 9. So the capacity of the change is 1 hour. The answer is $14 per day, per hour. The change of the optimal solution is $14 per hour. So if I change 8 to 10, what happens? After you find this value, rate of the change, you can consider for any other change without solving the problem, the new problem. I want to ignore the solve the problem again after I change the right hand side. So by using this formula, I found that the rate of the change is $14 per hour. So if I change 8 to 10, what happened? Means that the new value for Z is 128 plus 2 times 14, because I increased 2 hours. If we change 8 to 5, what happens?
-1.
If we decrease the time, decrease the right hand side, the new Z is 128 minus 3 times 14. So by using this formula, by finding the dual price, we call this value dual price. By finding the dual price, I can find the difference for objective function based on change of right hand side for constraints. So we'll stop here, we'll continue next week and next time on Friday. Try to find the